Section 1.1 is on recursively defined sequences. So the first thing I'd like you to take a look at is number 1. There's a sequence here of numbers 1, 1, 2, 3, 5, 8, and 13. See if you can look at it and determine the next 3 terms in the sequence. If you can, see if you can explain what the rule or pattern for the sequence would be. Alright, well, if you haven't figured it out, the next 3 terms are 21, 34, and 55. And the rule is, if you add up any 2 terms before it, you get the next term. So add 2 terms before it to get the next term. Alright, the next problem, number 2. A square table seats 4 people, 2 tables pushed together seat 6 people, and 3 people pushed together seat 8 people. So there's a diagram of the situation below. The question is, how many tables are needed to seat 32 people? Hint, you can draw diagrams, make a table, or find a pattern. So you can go ahead and try that right now. If you're stuck, I made a table. I put my tables here, and I put my chairs here, and made a table. So I knew when there was 1 table, there were 4 chairs, 2 tables, 6 chairs, 3 tables, 8 chairs, and so on. So I noticed the pattern here. As the number of tables go up by 1, the number of chairs go up by 2. And if you continue on that pattern, I found that with 15 tables, we would have enough seats for 32 people. Okay, main ideas of the section. We're going to look at the difference between arithmetic and geometric sequences. So the following are arithmetic, and this is not arithmetic. See if you can find the rule for each one of these and give me a definition for arithmetic sequence. If you can, go to geometric, find the rule for each one of these, and give me a definition of a geometric sequence. Okay, if you notice the first rule, these are increasing by 2 each time, so you can add 2 to get to the next term. The next, it's decreasing by -1, so it's like adding a -1 each time. The next rule would be add 0.5 each time. Okay, definition of an arithmetic sequence. You're going to add something to get to the next term. Alright, geometrics. Take a look at these and see how they differ from arithmetic. As you can see in the first sequence, they're going up by 2 each time, a multiple of 2. So you'd have to multiply by 2. The second one is multiplying by 1/3 each time. And the last one is multiplying by a -4. Okay. Definition of a geometric sequence, you have to multiply to get to the next term. Alright, so now there's some more notes, main definitions. Okay, the first definition is recursion. Okay, recursion is a process in which each step of a pattern depends on the step before it Okay, a sequence is an ordered list of numbers a term is each number in a sequence. There's a famous sequence called the Fibonacci sequence. This is actually the first example on the front page. 1, 1, 2, 3, 5, 8, and so on. This is the Fibonacci sequence. We looked at on the front arithmetic sequences. They have a common difference. The common difference is the number that it increases by each time. To find a common difference, you subtract one term by the one before it. And if we do that, you pick any term but the first term. So say we pick like the 7, subtract by the term before it. Here the common difference is 4. The recursive formula then, we say our first term is -1. To write that out, we pick a letter. In your book they use U. So they say U sub 1, or the first term is -1. And the rule is to get any term. So U sub n, you take the 1 before it, so U sub n minus 1, and you're going to add 4. A common ratio. To find a common ratio of a geometric sequence, you take any number and divide by the one before it. Okay, so an example right here, if we took a 4 divided by the one before it, -2, our common ratio is -2. Or in other words, you're multiplying by -2 to get each next term in the sequence. The recursive formula, again, you have to define your first term. And the formula to get any term is the term before it times -2. Okay, a couple example problems. Say you're in a concert hall where there are 59 seats in row 1, 63 in row 2, 67 in row 3, and so on. Write a recursive formula to find the number of seats in each row. All right, so let's make a table. Okay, so let's say we have our row here and number of seats. Row 1, there's 59. Row 2, there's 63. Row 3, there's 67. So you take a look at this. Are these going up by the same number each time when you add, or are you multiplying to get to the next number? And it turns out for this one, you're adding each time. Looks like we're adding 4 each time. So this is an arithmetic sequence. So to write the formula, we say, all right, the first term is 1. To get the next term, you take the 1 before it, and you're going to add 4. Okay, there's a way to do that in your calculator. Let's see if we can pull that up. All right, so in your calculator, we can do this by typing in our first number first. Let's see if this will work. Okay, so my first number is 1, so I'm going to type in a 1. Okay, so now that's the last answer. Whenever you see a U sub n minus 1, you can use your answer key in place of that. So if you hit second and the negative sign, that's like U sub n minus 1, and then you have +4. Okay, now every time I hit enter, it's the next number in the sequence. Okay. Alright, but first we should actually start with 59 seats. So let's try this again. Alright, so 59 is our first number. Alright, so it's our first row, the last answer, +4 each time. Okay, so if I hit enter, there's the second row. And we're trying to figure out how many seats there are in row 4 for part B. So this is first row, second row, here's the third row, here's the fourth row. So there's 71 seats in row 4. And to figure out which row has 95 seats, let's go back to the calculator. Alright, so that was row 4. Keep hitting enter and counting. 5, 6, 7, 8, 9, 10. Alright, looks like in the 10th row, there's 95 seats. Alright, a couple more example problems. Practice writing recursive formulas. Alright, so always define your first term first. First term is -10. What's the rule here? You have to decide if it's arithmetic or geometric. So are we adding to get to the next term, or are we multiplying? So what you can do is you can take any term and subtract to find the one before, or divide. So it looks like this is going up by 6 each time. So our formula is u sub n equals the term before it plus 6. Right, the next one looks geometric. It looks like we're multiplying by 2, -2 each time. So to write this out, we have u sub n equals, or u sub 1 equals -3. There's your first term. And the equation is u sub n equals the term before it times -2. Okay, so always write your first term and then your equation. Okay, that's it. So you can look at your calendar and you can start the assignment.